Okay, so page 6 of chi-squared. So again, we're doing chi-squared goodness of fit, and we're going to use uniform distributions that are not uniform. Okay, the grades for an economics exam for 300 university students are as follows, and it shows a row of numbers here. It's got different intervals titling them, and then the frequencies are below. The frequencies are really what you're going to use. Okay, the categories can be anything. I'm sorry. They could be anything except when you're doing normal or binomial distribution. Usually they're intervals of numbers or numbers themselves. Okay, so in this case, it's intervals of numbers. The grades are normally distributed with a mean of 65% and a standard deviation of 7.5%. Complete the expected frequencies table. We're just going to do what we did before. We're going to use these left and right intervals, the lower and the uppers here, to calculate the normal distribution percentage, and then we're going to multiply that times the 300 people that took the exam, and then we're going to get an expected frequency. Okay, so let's do the first one, and then you'll kind of see how we do that. So first we're going to do second distribution, normal CDF, and we're going to put 50 to 60 because those are the lower and the upper boundaries. And then we're going to put the mu and the sigma that they have here. The mu is 65 and the sigma is 7.5. So 65 and 7.5. And we paste. And it's going to be 0.2297, and we're going to multiply that times the 300 people taking the test, the exam, and that'll give us the quantity that we put in here. The expected frequency then is 68.92. What do you know? It's reflected, so it's symmetrical here. Then we're going to repeat it. We're going to do 60 to 70. Okay, so second distribution, norm CDF, and we're going to put lower 60, upper 70. And then the mu is sigma, and the standard deviation is 7.5% again. And then we'll do paste. And it gives us 0.495. And then we're going to multiply that times the 300 people taking the exam to find out what the expected number of people who get between 60 and 70 are. It's going to be 148.5. Okay. Okay, so we're done. This is the expected frequencies if the distribution is normal. Write down the number of degrees of freedom. Okay, so the number of degrees of freedom are 1, 2, 3, 4, 5 numbers in this row. It's going to be 5 minus 1, which is 4. Determine the results of a goodness of fit test at a 10% significance level to find out whether the data fits a normal distribution. Remember to write down the null and alternative hypotheses. So I'm going to write that the null hypothesis is that the grades of an economics exam are normally distributed. And the alternative hypothesis is the grades of an economics exam are not normally distributed. Okay? And that was the null and alternative hypothesis. Now we're going to do the calculation to see if we reject or accept these null hypotheses. So we're going to do stat, edit, and we're going to type the data in here, and I'm going to do that offline to not bore you. So first I put in the observed frequencies, which are 8, 72, 143, 71, 6. Put those in L1, right? And then you put the expected frequencies in L2. I copied them from here, 6.83, 68.92, 148.5, 68.92, and 6.83. And then you run the chi-squared GOF test. So you do stat, test, go up because it goes to the second page quicker. Press the D option, which is chi-squared GOF test, enter, and then you leave L1 and L2. because that's where we put our data, our observed and expected frequencies. The degrees of freedom is 4 because it's 5 elements minus 1. And then we just go down to calculate and we press enter. Enter. And our chi-squared value is 0.705 and our p-value is 0.95. Oops, something happened. Okay, so our chi-squared value again is 0.705. Our p-value is 0.951. We're going to compare those to the critical value and to the significance being sent. So we're going to compare the chi-squared value to 7.70779, and obviously it's much smaller, which means we accept the null hypothesis. And 0.951 is much bigger than the significance level of 0.10. So again, that means we accept the null hypothesis. So we're going to accept the null hypothesis, meaning it is uniform or normally distributed. And the reason is because the chi-squared value is less than the critical value, etc. Okay, so that's it for part D. Now we're going to move on to number 5. Okay, so the lifespan of light bulbs is normally distributed with a mean lifespan of 1,200 hours and standard deviation of 100. 400 light bulbs are tested and the results are shown in the table. So here's the observed frequencies, and of course we're going to figure out the expected frequencies by doing norm CDF again. So let's quit out of here. And then we're going to go to second distribution, and we're going to do norm CDF. And the first interval we're testing is 1,000 to 1,100. So 1,000 to 1,100. And the mean value is 1,200 and the standard deviation is 100. So for mu, we'll put 1,200. And the standard deviation, we will put 100. I'm going to paste. And that'll be 0.1359. And so 0.1359 refers to from 1,000 to 1,100. What we want to know is, what's the expected frequency? This is the percentage or the probability. We're going to multiply the probability times the total number of light bulbs, which is 400. So let's multiply that times 400. And then it's going to be 54.36 or 54.4. If we're looking for one decimal place, looks like they're putting one decimal place here. Okay, let's do the next one, which is going to be 1,100 to 1,200. So we go back into second distribution, norm CDF, and we're going to put 1,100 to 1,200. 1,100 to 1,200. And then we hit enter, and the answer is 0.341. 0.341. And then I'm going to multiply that times 400 light bulbs. And I'll get 136.5. Okay, and by the way, did you notice that the mean value is 1,200 and that 1,200 is the right side of this interval and the left side of this interval, which means that we are dividing the normal distribution exactly in half, right? And if we do that, that means that all these are reflected. So this interval, if you put 1,200 and 1,300 into norm CDF, you would also get 136.5. This one you would also get 54.4 because it's reflected also. And the last one you would get 9.1. Another thing that you might notice is, let's see, the standard deviation is 100, right? So did you notice that this percentage here was 34.1%? Remember 68, 95, 99? So this is also something that you could do to not use a calculator here, right? Okay, get rid of these stray marks. Let's go to the next step. B, write down the number of degrees of freedom. That's easy. You just count the number of elements, 1, 2, 3, 4, 5, 6. You subtract 1, and that gives you 5 for the degrees of freedom. That's a free point on the exam. Part C, determine the results of the goodness of fit test at a 5% significance level to find out whether the data fits a normal distribution. Remember to write down the null and alternative hypothesis. The null hypothesis is that the lifespan of light bulbs is normally distributed. Okay? And then the alternative hypothesis is that the lifespan of light bulbs is not normally distributed. Okay? So we're done with that. And then we're going to run the test. Of course, we do need to first feed stat-edit into stat-edit. We're going to put the numbers 24, 52, 92, 164, 42, 26 into L1, and then into L2 we're going to put the frequencies. So I'm going to go offline to do that, and I'll be right back. Okay, so I've put into L1, I put the observed lifespans, which are 24, 52, 92, 164, 42, and 26. And the expected lifespans I put in L2, 9.1, 54.4, 136.5, 136.5, 54.4, 9.1. And then I'm going to run stat test chi-squared GOF. Go to the second page, going from bottom to top because that's faster. I press enter. L1 and L2 I leave as is because that's exactly where I put them. The degrees of freedom this time is 6 minus 1 equals 5, so I put 5. And then I go down to calculate and I press enter. And the answer is chi-squared equals 78.8, and I'm going to write that down. And the other thing I'm going to write is that the p-value is 1.52 times 10 to the negative 15th, super small. And let me just rewrite that because it's very messy. Okay, and we're going to compare the chi-squared value to the critical value, which is 11.07. You can see that we're much bigger, so that means we reject the null hypothesis. And the p-value is much smaller than the significance level, which is 0.05, which also means we reject the null hypothesis. Okay, so the light bulbs are not normally the lifespan of the light bulbs are not normally distributed. And that's it for this problem. I think that they said to just state the conclusion, give a reason. We just did. So we're done with this page.